Hi everyone, welcome to the latest cadence features in Xschem through the use of Claude Code video. And this is what we're going to look at today. Signal browser is something you might have used in Cadence, and I'll explain more about what that is. And we have updated user experience for wire labels and pins as well. I don't know if you'll find this one useful. You can now press keyboard shortcut, or rather keyboard and mouse combination shortcut to select all of a wire, including the wire labels. And you can also edit the snap grid. Calculator is going to look just like what Cadence has, but that's a work in progress. Just show you briefly, but it's not done yet. So first of all, if you want to do something that includes Verilog A or Verilog, I believe you'd have to have ngSpice version 46. So let's look at what you need. So as you know, if you're on the fluid editing branch, you'll get this PDK launcher. So once you do that, let's just launch this one. And it's going to show you the sandbox. And this is the one. Now, what you need to do to be able to run something that has Verilog, this is a very basic test bench, as you're going to see. So I'll launch this, the analog design environment. We're calling it analog sim environment, just so we don't bother Cadence too much. So the schematic. So it's really basic. I think this was created by Claude itself, since everything finally lives as text. Right. Now, what do you need to be able to run this? Because it has Verilog. So you can see this guy, as you know, Control Alt S finds that in the library manager. So you look at the Verilog. It's very basic Verilog. Right. So this guy here, and I come to the test bench, will show you what you need to do to be able to run this. What do you need to install? So you have to, of course, you need a bunch of things, which you probably already have, but that tells you, okay, some things that you need. After that, you need ngSpice. The distro package will not do. So what you get with apt install won't do. That's version 42. You need version 46. So this tells you what you need to know. If you face a problem, when I first did it on this PC, it told me that there was a package missing. ChatGPT or Google can probably help with that. I had to install the XAW library. Once you've installed that, you install Verilator as well. That's something you need for running Verilog. Once you've done that, it gives you this command that runs a bunch of tests that tells you if your install is okay. And you can see I just did that here as well. It told me that everything passed. README is incorrect. It says 4 minutes. Now it's more like 20 seconds or so. That being said, let's see what happens with the Signal browser. So if I run this, it's gonna give me a log file. You might find there's some things that aren't totally stable, like you launch the waveform viewer and see, you saw what just happened. Okay, anyway, so it says it's down. So let's launch the waveform viewer. Okay, so it started off. There's some things that are intended to be plotted. Let's see if splitting the strip works. Move to separate strip now. That's not what we want to do then. Split strip. Okay. So here, what do you see? You see that the supply voltage V is 1.8, but what are these guys in the schematic? We don't have these waveforms, so let's look at the schematic again. See, that's what I'm talking about. The stability isn't 100%. There is something we're still working on. So we don't have count, we don't have counter 0, count dot 1, count dot 2, but I guess that's something that I don't know about how it handles a mixed signal simulation. But these are all analog voltages, right? Analog waveforms. They go from 0 to 1.8. So what about the digital? So that's inside here. So let's look at the signal browser. So you can do view signal browser or control V as it says. So when you do that, you get this. And now you're seeing it's something to do with these D2A elements. So that's how it plotted these guys. But what if you, so control N gives you a new waveform window and it's in single plot mode. So do control shift or to go into multi-plot mode. And if you do all DBs, then it gives you what the VCD file produced. So here you can do you add the counter, and these are the internal signals, right? So this is a very small test bench. I won't show you the hierarchy thing, but what you can do is you can descend to here in the schematic if you want, and that doesn't, I don't know what that does here. It's just one level, right? But I'll show you that with another test bench later. Okay. So now that you're here, you have some internal signals. So this is the actual, so these should all look digital, right? You plot one, plot two. So they go from 0 to 1. How about the count that it's maintaining? So you can see that's a variable that it's got inside. So that's really quick on the signal browser. And you can do things like, let's see here, 22 of 22 signals. What happens if you do count star? Okay, it does something. And how about here? Count star, it has no signals of its own. So let's say what happens if we do star? Count star? No, nothing. Okay, I guess I got to learn to use that thing better. Okay, what happens if you do count star here? Okay, show you something at that level. Uh, star, count star. Okay, maybe you have to go to that level to see that. Okay, okay, doing something, right? Okay, that's good. Okay, so that's it for the signal browser. I know it's really short. It is powerful. It's something that when you need, usually when you're working with a digital designer and there's a block that exists only in code and you need to debug top level simulation, you'll have to look at internal signals. So that's when this could be very useful. Well, let's look at the other things now. So let's go out of here, go out of here. I think I'll launch Sky 130. Actually, okay, let's launch that. And that as a test case, that's probably more pertinent to the hierarchy discussion. So let's come here and let's open this guy, TB band gap. Okay. That's what I'm talking about. Things not being totally stable. Control G. Now let's run this one. And before running, maybe I can quickly demonstrate the other things that I want to talk about. Okay, so wire labels. Okay, let's see if that works properly. So I said, if I move this guy, the wire label, okay, this is a connected move. Is it shift N? That's okay, you see what happened? It went for the right. Whereas before, it would have, it is when you place a wire label, you're placing an instance, right? So it would have stuck there and would have created two new wire segments. Um, Move this guy, and you see, rotate or flip, it goes along for the rest. Let's undo that. Nope, Control Z is, U is undo, sorry. Okay, that's back there. That is for no longer splits, goes along for the right. And then what about pins? So let's say a copy of this guy, which shouldn't have let me do because it should only be attached to a net, but that's okay. It's good for what I want. So I converted that to a pin, right? So now let's say I highlight this guy. Let's draw nothing's able to highlight this guy. So it is connected. Okay. Now what happens by changing this name? If you do that in Cadence, what you'll see is if you change the name, it updates the wire labels as well. So that's what I want to show. So undo on that, get rid of that so we don't change anything. Okay, so pins are shown. And then sometimes it's usually more useful in the symbol view. It works there as well. You see the snap grid is half of the minor grid, right? So if I do Alt up arrow and shown you what it did here. So now it's the same as the major grid, back and go down one more. Now it's 1/4. Okay, just want to show that real quick. So that's this guy. Calculator preview, calculator. So we're just started working on this. It's fleshed out. You'll have all the functions that Cadence gives you. I don't think you need the actual number keys. You just need the operators, right? Well, this guy just started working on this. Okay, so that being said, let's look at the hierarchy function. So let's run this guy. Hierarchy through the signal browser. So this one actually has some useful hierarchy we can look at. So let's look at this through the Xschem browser. Okay. I guess if you have a block with a lot of signals and some of the names are similar and you don't want to go hunting in the schematic, then it could be useful, I guess. Let's see. Let's get rid of the grid. Like here is this done. Okay, now it's done. Didn't remember asking for that, but interesting. We are in multi-plot mode. So here is what I mean by hierarchy. So Xschem browser, Control B, and it's got the design. Okay, let's design here. So let's say I want to look at signals in here. So I want to go to this level, right? So I can do Control Alt V, and we didn't do it. Why? Control Alt V here should get me to that level, but it didn't. Why? Interesting. No simulation data loaded. Read. That's not right. That's let's see. Waveform viewer. That's what I'm talking about. The stability isn't quite where we'd like it. So now it looks like it's gonna crash. Still not. Control G. Okay. But it still says there's nothing loaded. That's not good. It's completed a simulation, so it should have loaded the result, but that's not what we're seeing. Let's go back to the top. Let's plot something and see if it plots. Okay, plotted something. But why is it not cooperating? Let's go here. I should be able to do Control Alt V and go there. Okay, so now it worked. So we want to look at signals internal to this block, Control Alt V. How about this guy? Let's have them both visible together. So this is the kind of stability I'm talking about. You see how the display isn't really cooperating. So we are in single plot mode. Let's go into multi-plot mode, Control Shift 4. I come here, um, come here and do Control V. It should find that. Okay, found that. So here, let's say I want to descend to here. Okay, so it went into that block. So you see how that works. And I can plot signals from inside this block. Yeah. Okay, this is an X server thing. Okay, but that's really what I wanted to show. I think we hit pretty much everything. Yeah, it's not, other things are still a work in progress, but we're getting there. So thanks for your attention. Hope you find these useful. If you find issues, please put in issues on the GitHub, and Claude Code, I'm sure, will be happy to address them. Thank you.